Okay, so now we're going to transform the reciprocal function again. No translations this time, but what's happening over here in yellow? We have a big 2 that's out in front, so that means it's a vertical stretch by a factor of 2, and that negative affects the y values. Keep in mind our x is still intact, exactly the same as it was before, so there are no x transformations happening here. So if you can remember, the vertical stretch is probably the easiest place to start. So we go to our existing points on 1 over x, and we're going to have to move those in 2 steps. First one is a vertical stretch by a factor of 2, so double all these distances above the x-axis, so that y value is 2, it goes up to 4, 1 goes up to 2, and the y value of a half goes to 1. Similarly, on this side, we take these 3 ordered pairs, and you can use more, but 3 should suffice, and we double all those y values. That y value of -1 goes to -2, -2 to -4, and -0.5 to -1. Okay, so half done, and the negative, that affects the y value. So what happens when you negate those y values? Well, positives become negatives, and negatives become positives, so we're reflecting this across the x-axis as well. Okay, so let's just do that. So +4 becomes -4, and +2, -2, +1, -1. So I think I'll transfer these ordered pairs over to this graph paper before I'm finished, since it's sitting here nice and blank. But let's reflect these other 3 ordered pairs in the 3rd quadrant into the 2nd quadrant. So -1 becomes +1. I kind of missed there. That becomes +1, -2, +2, and -4, of course, +4. All right, now keep in mind, where are our horizontal and vertical asymptotes? Well, they're the same as the basic reciprocal function, since no translations happened here as well. So let's maybe just quickly recopy this nice and neat like over on this clean graph paper. So here's my horizontal asymptote, which hasn't changed, and my vertical asymptote, which hasn't changed. I can remember how to draw a straight line here. There we go. Okay, let's notch this out. And of course, you probably don't need to do this if you know it's your x and your y axis, but just to maybe help with the visual a little bit over here. And then these dots, sorry, I guess these little tick marks that are right here. And by the way, that should have been a little cross as well. So what is that? 2 and -1. All right, and that one is 1 and -2. And then at a half of a box, we went down to a -4. And follow our asymptotes. Don't cross them in this case. And there's our first branch. So because of the stretch and the reflection, our first quadrant piece from our basic reciprocal is now sitting in the 4th quadrant. And then these ordered pairs in the 2nd quadrant, the little tick marks, -2 and +1. -1 and 2. And at a half, we're up to +4. And again, don't stray too far from these points, but still follow your asymptotes. Okay, so there's our transform function, and before we finish off here, let's write down the explicit equation of this transformed function as well, without putting blotches all over the screen. Let's move this down some. Okay, so the explicit equation. Now this is actually pretty easy. We just put a -2 out in front of the original, which is 1 over x. And typically, well, you could leave it like that, there's nothing wrong with it, but we usually should clean that up a little bit and multiply 1 by 2. Of course, this is -2 over 1, so you could write this as -2 on the top, all over x times 1. There's nothing wrong with that, but usually we just want to make sure that we don't miss that negative, because of course that was an important feature to reflect our function. We put a negative in front of this fraction of 2 over x, and there's the explicit equation of our new function. And keep in mind, if you don't see any translations, you know where your asymptotes are as well. So you can try doing that on your graphing calculator if you're having some problems, and I showed you how to do that in the last video.